Hello students, today we are going to be solving a system of linear equations by elimination with multiplication. Don't forget as we go to take notes and do the survey at the end. Solving a systems of equations using multiplication. So far we have solved the equations by graphing and by elimination. These notes go one step further from elimination and actually use elimination with multiplication. The reason we have to use multiplication when we are solving by elimination is because sometimes both equations are written in standard form, but neither variable has similar coefficients. In order to get similar coefficients, we're going to multiply one of the equations by a number or both equations by two different numbers in order to get the coefficients to be similar. The steps we take to solve these are pretty much the same as last time. The only difference is in step 3, before you solve, you're going to multiply one of the equations so you can get the various coefficients to be similar. Remember, our solution is still written as an ordered pair, x comma y, so we still have to plug it back in the end and get our other variable. So let's look at this example again. We have 2x plus 2y equals 6 and 3x minus y equals 5. Our first step is, of course, to line up our equations. This is already done for us, so we don't have to do that. Our second step, choose a variable to eliminate. Try to make things easy on yourself and eliminate a variable where you have to do as least work as possible. So if you're looking at these two, you want to find a least common multiple between the two coefficients of a single variable. So we're either looking at eliminating our x's or eliminating our y's. When we want to do this, we want to figure out, okay, what can I multiply by one or both equations in order to get them to be the same? In this case, it would be easiest to eliminate our y's because we have a 2 here and a 1. All we would have to do is multiply this 1 by 2 in order to get these to be the same. So in this case, we're going to go with our y's. When we're eliminating with the y's, again, we can multiply that top equation by 1 and the bottom equation by 2. When we multiply here, it's like we're distributing. So if we multiply the top equation by 1, it doesn't change anything because multiplying by 1 keeps it all the same. When we multiply by 2 on the bottom equation, 2 times 3 gives us 6, 2 times negative 1 gives us negative 2, and 2 times 5 gives us 10. So it's kind of like you're distributing. Once you multiply everything in the equation by that number, you're not technically changing the equation, so we still have that same problem that we were looking at the beginning, but now we have these similar coefficients. So since we have these similar coefficients, we can then eliminate just like we did the other day by adding or subtracting. Since we have a positive 2 and a negative 2, we actually want to add these two together in order to eliminate them. So 2 plus 6 is going to give us 8, and 6 plus 10 is going to give us 16. In order to get x by itself, we divide by 8 on both sides, so x equals 2. Now we're going to plug this back into one of the equations. It doesn't matter which one you plug it into, just like we saw the other day, as long as you plug it into one of the original equations that you have. So let's just go with the first equation. We had x equals 2, so we're going to put 2 in for x. 2 times 2 gives us 4. If we subtract 4 from both sides, we have 2y equals 2, and then divide by 2 on both sides to get y equals 1. We want to write our answer as an ordered pair, so our answer here is 2, 1. Now, if we had used in the very beginning to eliminate our x's, we should still get the same answer. So let's take a look real quick. So we want to multiply both of the equations or one of the equations to get common coefficients. In this case, we have to multiply both equations by a number. So we need to multiply that top equation by 3 and the bottom equation by 2 in order to get those similar coefficients of 6. So 3 times 2 is 6, 3 times 2 is 6, and 3 times 6 is 18. 2 times 3 is 6, 2 times negative 2, 1 is negative 2, and 2 times 5 is 10. So we have the similar coefficients. In order to get these to get 0, we're going to subtract. When we subtract these, our 6x's cancel. 6y minus negative 2y gives us 8y, and 18 minus 10 gives us 8. Divide by 8 on both sides, so again we have y equals 1, which is what we got the last time. Again, we want to plug it back in to get our x value. Because we plugged it back in the first equation last time, let's go with the second equation this time. But again, it doesn't matter which one you pick. If we go with the second equation, we're going to put 1 in for y. In order to get x by itself, we add 1 to both sides, so we have 3x equals 6, and then divide by 3 to get x equals 2. So as you can see, we get the same exact answer even though we did it a different way. So get another example. We have x plus 4y equals 7 and 4x minus 3y equals 9. We want to line the equations up, which they've already done for us. Step 2, choose a variable. Remember, you want to make this easy on yourself. Don't put yourself into a lot of work by choosing one that you have to multiply both equations. On this one, again, your coefficient of x is 1, so you could multiply that top equation by 4 in order to get the x's to be the same. That's the easiest route, so let's go with x's. Alright, so we're going to multiply that top equation by 4 and the bottom equation by 1. So the bottom equation doesn't change at all, but the top equation is now 4x plus 16y equals 28. So we have our similar coefficients here. In order to eliminate them, we're going to subtract. 4x minus 4x is 0. 16y minus negative 3y is 19y. And 28 minus 9 is 19. If we divide by 19 on both sides, we have y equals 1. So now we want to plug this back into one of the original equations. Let's go with the first equation. Again, if you went with the second equation, you should still get the same answer. If we put 1 in for y, 4 times 1 is 4. Subtract 4 from both sides, so x equals 3. So our solution on this one is 3, 1. If we went with substituting this into the second equation, which we could have done, let's see. We put 1 in for y, so 3 times 1 is 3. Add 3 to both sides, so 4x equals 12. Divide by 4 on both sides, so x equals 3. So we still got the solution of 3, 1. There's a lot of different ways to do these. You just have to make sure you're using the right numbers at the right times. I apologize for this. We're going to skip on through this. Alright, we can also do word problems. So just like the other day, it'll give you 2 situations and you have to write an equation from it. So on this one, Ashley School is selling tickets to an annual dance competition. On the first day of ticket sales, the school sold 7 adult tickets, so we're going to have 7A. And they sold 3 student tickets, so we're going to add this at 3S for a total of $100. On the second day, the school took in $160. They sold 6 adult tickets, so we have 6A plus 10 student tickets, so plus 10S, and that would equal a grand total of $160. What is the price of 1 adult ticket and 1 student ticket? I want you to use what we just learned in this video, solve this equation to figure out what an adult ticket would cost and what a student ticket would cost. Please do that now. Tomorrow we will discuss the answers in class. Make sure you take notes, complete this problem, and take the survey at the end. Bring your questions to class tomorrow and we'll do some practice. See you tomorrow.